Hello and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of circumference and area of circles. This is standard 7.9b in the great state of Texas, and we are using item number 32 off the 2017 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a rotating lawn sprinkler that actually makes a nice little circle here. And the diameter of the circular area is 16 feet. So the diameter is a line that goes from one side to the other through the center. So let me just see if I can draw a straight line here. That's the diameter right here. And they give that to us as 16 feet. Now, how I remember the diameter is the line that goes straight across. I think of this prefix di, which actually has the same meaning as bi, which means two, and the diameter cuts the circle into two equal parts. So a diameter makes halves is what it does. So we've got that as 16 feet. So I'm looking for the measurement that is closest to the area in square feet, and so the area is the inside. Now area, we've been dealing with area since the 3rd grade. Area is the inside. You put little squares in there. Problem with area of a circle is when we're looking at area, we're used to length, width, height, those types of measurements. There's no corners, there's no straight lines in circles, so we need to use something else. So how do we find the area of a circle? The area of a circle is a very simple equation, pi r squared. Now pi is actually known to us. So pi is actually the ratio of any circle, and you have the circumference, let's put that correctly, the circumference over the diameter. So the circumference is the outside, and you take that any circle, you take the outside, divide it by the diameter, which we've got here, and it's always going to be this same ratio, which we think is about 3.14. We say we think it's about because it's actually an irrational number. It never stops. It goes, if you divide the circumference by the diameter, it goes on and on and on and on and on. It's not repeating. It never stops. So we use this symbol pi, it's a Greek letter, to represent this ratio of circumference over diameter. So that's what this pi equals. What we need is the radius. And the radius of any circle goes from the center and it goes out to the side. And so this right here is our radius. But you can probably see the relationship between the two pretty simply. If this whole thing right here from side to side is 16, and the radius goes from the middle to the side, well, that makes sense then that the radius is simply the diameter divided by 2. Or sometimes we'll say this, we'll say the diameter is double the radius. That's the relationship there. You take the diameter, you cut it in half, you have the radius. So my diameter in this problem is 16. So 16 divided by 2, so 8. So now I've got my numbers. So our area, remember, is going to be 3.14 times our radius 8 squared. So this 8 squared does not mean 8 times 2, it means 8 times itself. So 8 times 8 is 64. So we're going to take our 3.14, multiply that by 64. That's going to be pretty big, but let's just go ahead and do that real quick. We'll get our answer. 4 times 4 is 16. 4 times 1 is 4, the 1 is 5. That's 12. So now we've got 24. 6 times 1 is 6, and the 2 is 8, and 6 times 3 is 18. So I've got 6, 9, 10, another 10. 20096, remember 2 digits behind the decimal in the factors, 2 digits behind the decimal in our product. 296 hundredths square feet H.